Okay, for this demonstration of our additive manufacturing extensions, we're going to start with our Royal Enfield motorcycle assembly here. Let me call that up. Okay, we've got a couple areas we're going to work with on this particular new bike. I'm going to start in the muffler area, the exhaust system. Let me go ahead and hide the casing here. So the front section of this muffler is actually where the sound attenuation starts, and the current design is basically just holes, if you will. Very simple, but the idea is we can manufacture this very quickly and in great detail. Let me go ahead and cut away on this part. You can see what I'm talking about here. So that provides the start of the exhaust control there, but maybe we want to get something different here. So if we've got maybe a 3D printer that we could work with, well, we can get a lot more complicated than that. So let me go ahead, let me just turn the center area off, and instead, let's fill this with a lattice. So a lattice structure can be very simple, very complex, but the idea is a 3D printer has no problem making something like that. So we say, I want a lattice feature inside of Creo. You define the boundaries. Basically, I want to fill this area, either a cavity or a pocket and so forth. And then you say, what sort of cell, what sort of lattice arrangement do I want? So in this case, I'm going to use one of the newer ones that we have within Creo 7. And you'll see you start with, regardless of the type of cell you're using, is how big is it? What size are the nodes? What are the size of the actual arms or extensions, if you will? What sort of cross-section? Once you've got that set the way you like, you say turn it on. And then you get a lattice structure. Just like that, you have a full BREP designation of a lattice structure that you can then take to the 3D printer. And there's lots of different options there. This is a huge area of R&D for the additive world, and we can support them. So maybe something simple like a 2.5D lattice, I'm going to go get for more of a hexagonal, if you will. Say set that shape, set the size, set the options. There's lots of different options you'll choose when determining how you want your lattice to look. In this case, I want to round off the inside radii, things like that. And any point, you say, show me, and it goes ahead and builds that. It builds it as a single Creo structure that you can edit, you can modify, you can look at the weight, you can look at the strength, and use it in your analysis. So we also have more formula-driven. So these are also a big area of research here. So let's go ahead and do more of a gyroid shape. And something like this just completely changes all the rules of what a muffler section, a center section could be, because much more complex than just pipes going through. We've got something that looks like this. And again, you can choose different ones. You can try different ones, see how they're going to work. Go ahead and test it out. Say if, yep, that's a brand new type of muffler, and it works great. And it's something that can only be done with a 3D printer. And that's really what this extension is all about, is taking advantage of those capabilities that you now have on your manufacturing floor, whether it's just for prototype or whether it's for truly building production-ready parts. All right, so that's the lattice structure. That's one of the first main capabilities you get with the additive manufacturing extension. But there's also the printing of the actual parts. So maybe we're going to print this outer case. I want to make it out of a different material. It's a pretty complex piece. It takes a lot of time to machine it or to make castings and then machine it down to shape. But maybe we want to 3D print it, more of a net shape where we just go in and machine bosses and holes and so forth. Maybe that's going to be a much faster way, allow me to use some different materials, maybe that don't do well with castings and so forth, or really cut down on that machining time. All right, so now I'm going to just do normal sort of Creo. I'm going to make a manufacturing build version of this part, and to do that, I'm going to take off all of these cuts and so forth. So just really worry about the little features that we are going to machine in a secondary step after we print it out. So you can see I'm just using flexible modeling capabilities to remove sections, to offset, add some material where we're going to need to machine down, things like that. Just standard Creo functions to build my workpiece that I'm then going to send to the 3D printer. All right, so I've got all of those, either, again, offset, turned off, remove, whatever function makes it easy, but that's the net shape that I want to print. So let's go start it up. So the first thing I'm going to do is I'm going to build a plane here at the bottom, because I'm going to use that to determine what's the optimal build direction. This is a issue of, if I just put that flat into my printer, I'm going to have support structures over almost the whole interior here, assuming it's facing down, because if it's anything over a certain angle, I have to be able to put support structures inside the 3D printing process, and those have to then be removed later. Well, what if I go in and actually analyze this model and say I want to have a like a 45-degree print, self-supporting? What's the best way to position this part? Well, I can actually use AMX to calculate that. Say, go calculate an optimum build direction that I can use in my 3D printer. And it's one of those, depending on the types of shapes, the complexity, and so forth. Some of them are very obvious, and some of them, a piece like this, not even remotely obvious. It's not a boxy piece of any shape or size. So let's let Creo figure it out. So you can see it goes in here and it tries different orientations, looking for what's working best. As it gets better and better, it's going to keep solving until it converges. And the end result of that is very simple. It's just simply a coordinate system that says this is the optimal build direction based on the critical angle for your self-supporting process on your particular printer. All right, and so that just comes in as a Creo datum as part of this model. So now I want to take that model and lay it out on a tray and build support structures. So I start with that. So here is the printer tray. I go ahead and choose whichever printer I have, and that's something you simply add in. You can have just standard printers, especially plastic and so forth. We have direct interfaces for all of those, and then all of the metal printers, we use the materialized build processor method. So you can obtain build processors for various machines, and then right here in Creo say, okay, that's what we're going to use. Here's the machine, here's the envelope, my printing envelope, and then how do you want to position that part? Well, here's where I'll use that coordinate system. And rather than me orienting it to any particular angle, I'll say, no, use that build direction. Once I've got it set into my tray, I've got the appropriate orientation. Now, let's go ahead and build those support structures. So you can see those are really tied to your processes, what kind of material you're using, what sort of printer, and so forth. So you can actually set those. You can start with defaults, go ahead and build the support structure based on all of that. And you can see it all happens in Creo. Again, you're not having to go out to separate software, maybe losing track or not being able to update when the part updates. But here, I just choose whichever process I'm working on. So in this case, I think we set that build direction with basically a 45-degree critical angle. So if that's my self-supporting angle here in the print process, I'll say 45 and go build those support structures. So you can change. You can print it on one machine, different one type of material, and then change with a different set of parameters to build support structures for those. But based on that build direction, based on those parameters, now I have my support structure. So I can take that into my printing, into the simulation. I can say, go ahead and show me the slices, build me a CLI file off of this support structure. Takes just a second, but again, you can see I'm still in Creo. This is a Creo print tray, but it's a Creo assembly that I can keep track of, I can modify, In this case, if I look at the top, I can say, show me these slices. Show me what's going to happen with this printing process, and show it to me inside of Creo. And that's really the key here, is get all this intelligence and work right on the Creo model, the Creo secondary model with all the material removed for secondary machining, and then put it in a tray. We're going to print this out of plastic, out of metal, using this particular machine. Here's the slices that we need to do that. That is, along with the lattice capability, all of that is within our additive manufacturing extensions as part of Creo Parametric.